There's another pathway to NAD+ production that doesn't get as much attention as vitamin B3, but it's equally important: the conversion of tryptophan into NAD+. Tryptophan is an essential amino acid, which means your body can't make it, you have to get it from food, specifically from protein. And here's what matters: your body can take this amino acid and, through a longer but completely viable metabolic pathway, convert it into NAD+. This gives us a second dietary route to supporting brain NAD+ levels, and it's one that's particularly relevant for older adults. Foods rich in complete proteins, meat, poultry, fish, eggs, dairy, soy, and quinoa provide tryptophan alongside other essential amino acids. When you eat adequate protein, you're not only supporting muscle mass and immune function, you're also providing the raw materials for NAD+ synthesis in the brain. The positive perspective here is really important for aging populations. We know that protein intake often decreases with age. Older adults may eat less overall, have reduced appetites, face dental problems that make meat difficult to chew, or deliberately restrict protein due to cost or outdated dietary beliefs. This protein deficiency can have serious consequences beyond muscle loss. It may directly limit the brain's capacity to produce NAD+ from tryptophan. Research suggests that the tryptophan to NAD+ pathway becomes increasingly important when other NAD+ precursors are limited. If someone isn't getting enough niacin, their body can compensate by converting more tryptophan. This metabolic flexibility is elegant, but it requires adequate protein intake to work. If protein is deficient, both pathways suffer. Now for the more sobering analysis. The tryptophan pathway is less efficient than direct niacin conversion. It takes more steps, requires more enzymes, and produces less NAD+ per unit of precursor. In a young, healthy person with good overall nutrition, this inefficiency doesn't matter much. But in older adults, particularly those with inflammation, metabolic disease, or poor gut health, the tryptophan pathway may function even less efficiently. You can't simply assume that eating protein will solve NAD+ deficiency problems. There's also the issue of competing pathways. Tryptophan doesn't only make NAD+. The body also uses it to produce serotonin, a neurotransmitter crucial for mood regulation, and melatonin, which governs sleep cycles. When tryptophan is limited, the body has to allocate it among multiple critical functions. This means that simply increasing protein intake might not translate directly into more brain NAD+ if other systems are demanding that tryptophan for their own needs. Another warning relates to protein quality and overall diet balance. Not all protein sources are equal. Processed meats, while containing tryptophan, also bring saturated fats, sodium, and potentially harmful preservatives. The goal isn't just to maximize tryptophan intake, it's to support NAD+ synthesis within the context of an overall healthy dietary pattern that doesn't introduce other risk factors for cognitive decline. What should we take from this? Adequate protein intake is genuinely important for maintaining NAD+ synthesis capacity, especially in aging. For older adults, aiming for roughly 1 gram of protein per kilogram of body weight daily is a reasonable target, adjusted for individual health conditions. This supports not just NAD+ production but overall metabolic resilience. But protein alone isn't a magic bullet. It works best as part of a comprehensive nutritional approach that also includes niacin-rich foods, antioxidants to protect NAD+ from excessive consumption, and anti-inflammatory components to reduce the metabolic stress that drains NAD+ in the first place. The brain's energy needs are complex, and meeting them requires a multifaceted strategy, not a single nutrient solution.